I want to thank you for joining me this morning on this dreary Wednesday in Cape Breton. Anyway, we are going to be using the chat and the Q&A, and I have Michelle with me today, and she's going to be monitoring the chat and the Q&A for me. So if at any time you have a question that comes up, if you could just put it in the Q&A under the session, she'll be kind of monitoring that as we go. Their session is being recorded, so I just want everyone to be aware that the session is being recorded. And I think everybody is okay with the polls and the Q&A, so we'll get started. So the session today is on developing concrete understanding for fractions and decimals. I know it was listed as M4, but if you're teaching, grade 3, 4, 5, in grade 6, I'm sure that maybe something in the session will be able to you'll be able to take with you. We are realizing that students need significant time to develop these deep conceptual understandings for fractions. So the session kind of evolved out of that. And this is me. So my name is Jillian McNeil. I'm currently a mathematics coach for P-5 in the Cape Breton Victoria Regional Center for Education. I was an elementary classroom teacher for about 10 years before I started the role as a mathematics coach for P-3. Currently, I'm in my 8th year, and the position has evolved into a mathematics coach for P-5. I work with teachers in the classroom, trying to build best practices, but also using a student-centered approach to coaching. So this session kind of evolved by working with teachers in the last few years to develop a concrete understanding in response to some of the provincial data results from the M6 that we were seeing. Within our region, we have a middle school model. We noticed that students were leaving elementary after grade 5 and entering a new building, new teachers, new friends, and noticing that they weren't really retaining many of the skills that we believed were developed in 4 and 5. In conversations with teachers, we heard some of their concerns. They felt pressure to move quickly through the curriculum. For decimals and fractions, and based on the time of the year. They felt like the best way to move quickly was to jump really quickly to algorithms and rules, which they felt that the middle school teachers kind of had as an expectation. But they felt like they didn't really have the confidence either to use rich hands-on manipulatives for fractions and decimals. So they felt like they needed a little bit more PD around how to use these manipulatives. So through these conversations, we developed some key manipulatives that we were trying in the grade 4 and 5 classrooms. We were trying these on a daily basis through lessons and mental math experiences. Because we kind of wanted to help foster some of that deeper understanding so the students would carry that with them. The idea that the role of the manipulative is not to be better at an algorithm kind of came out of that. So today we're just going to review a couple of the tools that we worked with in conjunction with the teachers in the classroom, and they may be some of the tools that you're already using. You might find a new way to use an old tool and incorporate these into your lessons or perhaps your mental math. So the manipulatives that we're going to take a look at in this session are the Cuisenaire rods. We're going to take a look at the pattern blocks. We're going to look at the 10 frames. the Rec and Rec, base 10 blocks, the beat it number line, and the meter stick. We're going to look at some ways to use some fraction cards, and we're going to just take a look at a couple of Mathagon activities that we've used in the last couple of years that students seem to respond to. All right, so if we take a look at this problem, Allie and Jess bought the same chocolate bar at the store. Allie ate 5/6 of her chocolate bar, but Jess ate 6/8 of her chocolate bar. Who ate more and who had more left over? So in this classroom, we were looking at ways that a student might approach this problem. And if you think about how your students might approach this problem, they might consider 5/6, and they might consider 6/8, and possibly choose 6/8 because both the numerator and the denominator are bigger. So we were noticing that students were just kind of generalizing bigger means more. So they were kind of choosing that as an answer. But I want to click on the Mathagon tools. And what we saw was if we used some of the fraction bars to help students model this, they were kind of coming up with different ways that they were answering this question. So if they have the one chocolate bar that they both bought, which was the same size chocolate bar, and if we think about what they ate, so the students, and they really love using Mathagon, so we found that it was a really friendly way for students to build this visual. 5/6 of the chocolate bar. And then if someone else was to eat 6/8 of their chocolate bar, now the students had more of a concrete visual to help kind of figure out, okay, who ate more, who had more left over, and then they could kind of use this idea of one to anchor what they're thinking. So once they saw this, their answers became a lot different. So they were saying, you know, that 5/6 is larger than 6/8, but we could also see that, you know, this student, they were 1/6 away from the whole, and that this student was 2/8 away from the whole. So this was a larger piece away from one. They also came up with some answers which were surprising, where they started to kind of anchor where half was. So some students said, well, I can see that this student was 2/6 away from a half, and this student was 2/8 away from the half. So they could easily see a little bit clearer how to solve this problem, rather than just kind of writing out the two fractions and generalizing where they thought would be the bigger piece, or who would eat more. So I'm just going to come back here. So the Cuisenaire rods were another tool that we started really using. And I love when we find a tool that's really versatile for the whole school. And we had purchased a class set of the Cuisenaire rods for the primary 1 classes because they were working on different ways to make 10 and partitioning the number 10 and partitioning numbers in different ways. But we really kind of grabbed those out of the primary 1 classroom, and we brought them up to the 4s. And once we did that and handed them out, the students were really getting excited trying to use the same tool, but for a new purpose. So these were just some of the ways that we kind of introduced the unit. We were looking at how many ways can you represent halves, thirds, fourths. What did you use for one? And with the Cuisenaire rods, the conversation about changing one was coming up a lot more often than it had been, so which was really great. So modeling halves and fifths. What if the orange bar is 1? What did you notice? Which is the larger part? All of those really great questions were kind of coming up as the students were exploring it. So I'm just going to click on this link because we do have access to the Cuisenaire rods in our Pearson tools. So again, I also love when we have a tool that easily has something virtual that can go with it, because this is a great extension for the students. So when we were using these with the students at their desk, they could also open up their Chromebook and pull on the relational rods. And what I was asking them to do was kind of take the labels off. That way we took like the number out of the equation. So it was a little bit more friendlier for some of our students if they could just kind of look at what bar is 1 and how can we find equal parts. So students were exploring at their desk, but they were also kind of transferring this to this kind of pictorial online version. So they could figure out that if the orange bar is 1, we can see that the yellow bar is going to represent 1/2. And if we have 2 of them, we have 2 halves that make up our 1. I was also encouraging them to find other ways that they could break up the orange bar into equal parts. So some students discovered that if they pulled in the orange bar, they could also make equal parts of 1. Oh, sorry about that. These are just a little bit tricky, so they have to kind of snap together. But once the students started building these, they could also be able to talk about equivalency. So we can see that, you know, what is 1/2? What are some different ways to make up 1/2? What's going to be larger, 1/2 or 3/5 possibly? So all of these conversations kind of came into play when working with the Cuisenaire rods. But again, we really wanted to talk about the idea of 1. So we would change up what we would use as 1. So can you find equal parts of the blue bar? And a lot of students discovered that they could find thirds. So just introducing that conversation at the beginning of grade 4 really helped us talk about equal parts. So I just kind of wanted to share that that was some of the ways that we use the Cuisenaire rods. The pattern blocks, we also kind of, again, we went down to the grade primary 1 room, we took the buckets of the pattern blocks, and it's another tool that students are comfortable with because they've been using this tool for a really long time. But now we're kind of repurposing and changing in the way that we talk about the pattern blocks. We also noticed in some of our regional data that the students were having trouble representing fractions with pattern blocks. And I think the teachers were kind of talking about how they didn't realize that the pattern blocks, that the students would have trouble with the pattern blocks and representing fractions with pattern blocks. So again, we reintroduced those into the classroom. So considering the problem, which fraction is larger, 2/3 or 3/6? Again, we still were having some of those students, oh, the numerator's larger, the denominator's larger, so that must be a larger fraction. So what I'm going to do is I'm just going to click on the pattern blocks, and we're going to use, I really like Mathigon for this one. So we're going to take a look at how the students were using the pattern blocks in Mathigon. So if we have our 1, so we're using the hexagon as 1. Sorry, I have to keep remembering to click share that screen instead. So the problem that the students were exploring were which is greater, 2/3 or 3/6. So we noticed that the students really were comfortable with being able to figure out what blocks could kind of show 3 equal parts of 1. So they had this no problem. So they could easily model this using Mathigon. And they could see that, you know, 3 parts of 1. So if I have 2 of those parts, we're going to leave those there. And then the conversation really is surrounding that we're looking at the same size whole. So if we have the same hexagon and we break it up into 6 equal parts, again, the students were comfortable in knowing that the little green triangle in the pattern blocks it's going to take 6 of them to make up this hexagon. But where they were struggling was, how can I figure out which of this, what's larger? So once we show the students this model and how they can manipulate the pattern blocks, they kind of were easily drawn to see that, 3/6, oh, that's the same as 1/2. I have 3/6 here that's not filled in. I have 2/6 here. They look like they could fit 2 triangles there. So using this model for the pattern blocks kind of just helped a lot of our students visualize what that actually means to have 2/3 of one and 3/6 of one. And again, that kind of really moved into a grade 5 curriculum as well, in comparing fractions with different numerators and different denominators. So looking at equivalency, so 3/6 is the same as 1/2, but 2/3 here, that's definitely, I can see that that's greater. So and again, the students loved using the manipulatives at their desk, but they also love transferring that to Mathagon. So from there, we also kind of introduced the 10 frames again. Again, I love using something that comes from primary 1 and using it in a new way. So what we started to do was, into our mental math, exploring tenths with the 10 frames. And if we make the 10 frame now equal to 1, how would we represent 7/10? So we started playing how many, and as a math coach, I was playing how many in the classroom with the primary ones a lot. So once they saw me in 3, 4, and 5, they were always like, can we play how many? Can we play how many? But we just kind of changed it up a little bit. So I'm just going to kind of click on the Pearson tools for this one again. So as you may be familiar with how many, it just kind of flashes the 10 frames for the students. And usually we're looking at the 10 frame is equal to 10. So we've been playing that up until grade 2. But now I had the students use their whiteboards. And if we make the 10 frame equal to 1, let's play how many? And I would flash the 10 frames and the students would say, okay, I see 1, 2, and 5/10. Now, if that's a little bit fast for your students, you can kind of add some more time. You can also adjust the options here for the numbers if you want to start off with just, a single 10 frame. And have the students talk about, okay, what do you see? If the 10 frame is 1, we have 10 equal parts. And then they were starting to write them on their whiteboard. I see 4/10. What does that look like as a fraction? What does that look like as a decimal number? And you can continue to play. We would do like maybe, 7 minutes, 5-7 minutes in the morning, just to kind of get their brains warmed up. I see 1/10. And then the conversation about, okay, I see 10/10. What do you see? I see 1 whole. But just changing up that idea of what is 1. So now the 10 frame is equal to 1. But you can also use the explore if that's a little bit fast for the students, and also exploring how we can see that 5/10 is the same as 1/2 of the 10 frame is a really great visual for students as well. So I just kind of linked a couple of questions here that we used as prompting. How many more are needed to make 1? Is it closer to 0? Is it closer to 1? What about 1/2? Is 7/10 closer to 1/2, or is it closer to 1? And how many more would we need? All of those are great conversations to have with the students, and just helping them to build that understanding of parts of 1. So the Rec and Rec, I've been using the Rec and Rec for a lot of for a lot of years. And I always found that the students really responded to the Rec and Rec. And I loved in primary how they were using it to anchor 5 and anchor 10. So when we were looking at the 10 frames, the students were asking, can we play how many with the Rec and Rec? So what I love about the Rec and Rec is now the students can kind of extend that to thinking about parts of 1. So what if the whole Rec and Rec is 1? How many equal parts do you see within it? And the students, once they had familiarity with the 10 frames, it was a little bit easier for them to kind of transfer that to the Rec and Rec. So if we want to model 25 hundredths, how could we write that using, or how can we model that on the Rec and Rec? And now we have 100 equal parts of 1, but we can, a lot of students also can still see the 10 equal parts within the Rec and Rec. So I'm just going to click on the Rec and Rec here. I kind of like to hide this just so the students don't really get too confused with whole numbers. And now I'm going to add all of my rows for my Rec and Rec. And the students love modeling with this, but we also have sets of them in our classroom. So I would model for students on the Rec and Rec. And for those of you that use the Rec and Rec a lot, you know that you like read this white side. And also encouraging them to do those like 1 pushes. So how can you model 25 hundredths? We see 2/10 here, and we also see those little 5 hundredths as well. So having those conversations with students, how many different ways can you see this? And being flexible with how they see it. Well, I can also say that I see 1/10 and I can see 15 hundredths. So just getting the students to be a little bit more flexible in how they see those numbers when the Rec and Rec is 1. We can also kind of get them to play how many. So let's play how many. We can adjust them with the little hamburger here in the corner, the same way we did with the 10 frames, using their whiteboards at their desk. How many do you see? Oh, it goes away. But again, getting them to kind of think in terms of what they saw quickly, or if you want to add more time, if you feel the students aren't really there yet, that's okay. Can they write it as a fraction? Can you write it as a decimal number? I see 23 hundredths. If the whole Rec and Rec is 1, oh, I see they might write that as 2/10. How can we write that another way? So lots of really great conversations around what they see on the Rec and Rec. They might see the 100 equal parts, they could see 10 equal parts, but either way, they're being really flexible with their thinking and the way that they're seeing those numbers. So I just kind of included a couple of little prompts there on this slide, the things that we used with our mental math and conversations that we had. Is it, how many more do we need to make 1? Is it closer to 1? Is it closer to 0? Is it close to half? All of those really good conversation questions. So we're going to take a look at the base 10 block. So this might be something that you're already using, a little bit more familiar with. And I think this is probably the most common tool for changing the value of 1 and looking at fractions and decimals and representing decimals in a concrete way. We found that the students in the school were probably the most comfortable with this tool. But then one day we decided to play a game of kind of how many, but we continued to change the key. And it was a real kind of eye-opener for us, because the students were really great when the flat was equal to 1, or when always the large cube was equal to 1. But then when we started to go back and forth, we noticed that the students were struggling a little bit. So they were kind of falling into the trap of, oh, it's always going to be this, and then it wasn't. So what we did was, using the base 10 blocks from the Pearson tools. We had been doing all of this with the students for like, say, 2 weeks. And then all of a sudden I went back to the small cube was equal to 1, and I put a number up on the screen, and the students, they were stumped. They couldn't understand how that was 221 because they had been working with a different key. So being really flexible with this key, and I like the Pearson tools because it allows you to be flexible with the key, and it also allows the students to see the representations in more of a symbolic form. So changing up the key often kind of helped us. So I just wanted to kind of include this because if you change the key, the conversations around what that looks like is really great. And having the students kind of be flexible and making their eyes drawn towards the key, I think is also really important for them moving into middle school. So I included on this slide just some prompts. Show students the groups of blocks, ask them to identify the number represented, how many different ways can you make the number that we have, and being flexible with the key and changing up the key often and not just falling into the trap of, okay, the flat's always going to equal 1 now. So if you're familiar with Nikki Newton, I included the link for her video on how to use the Beat It number line. And this was also another tool that the students were familiar with because they had created them in 2nd grade. We were making them in 2nd grade when they were counting and representing numbers to 100. But now they were using the Beat It number line in another way. So we kind of went down, found some of the things that they had in the 2nd grade and brought them up to 4th and 5th. And being able to kind of use this tool to represent, okay, now my whole Beat It number line is equal to 1. How can we explore tenths and hundredths using that? And I really like also making the connection to these. These are kind of like the little laminated number lines to 100. But I would have the students write those benchmarks 0 and 1 instead. And these are dry erase. And I kind of included the spectrum link there in case anyone's interested. So what we used in the classroom were these like little tiny mini clothespins, and that's what Nikki Newton uses in her video to help students place and see where numbers would land on this Beat It number line. So students can compare their number lines. They can put their clothespins in different positions. They can put their clothespin where you kind of ask them to place their clothespin, and then they can extend that to where is that going to land on the number line. And having those conversations about where they put their clothespin. So is it close to 1? Is it close to half? What do we notice about 25 hundredths? What do you think that that's the same as? What about 5 tenths? What does that also look like to you? Or 3/4, where would 3/4 land? And how can we write that as a decimal? So the Beat It number line, again, it was something from grade 2, and we brought it up to the grade 4-5 class. And again, it's just another fun, exciting way for students to help build that idea of, okay, this is a number line. This is where these numbers go on the number line. The meter stick, I've kind of, I don't know, I included this link for the meter stick on Spectrum because I like this one probably the best. We still had a lot of students struggling with exploring like the length model in terms of tenths and hundredths. And we placed all of these on the floor and we started doing some games along the meter stick. and thinking about the meter stick as a number line. So instead of 0 to 100, we're now looking at the end of the meter stick as 1. So how many different parts can you see within the meter stick? And I liked the picture that I've included here, because we can also see tenths for some of our students that are still kind of trying to understand what tenths are, but we can also see some smaller parts, and we can see the hundredths. And if you flip that meter stick in fifth grade, you can see like all of the different parts of for thousandths. So we started playing a lot of games like, and we would line up multiple meter sticks along the classroom, and the students would, use these counters and do the little thumb toss and compare where their counters landed and what did you land on? What does that look like as a decimal? What does that look like as a fraction? Whose counter went further? And what did you notice about where your counter landed? There's a lot of different games that you could play along the meter stick. You could play almost like a race to one. You can roll the dice. You can have the dice represent tenths and create a number less than 1, or you can roll 2 dice for hundredths, place the counter along the stick and compare with their partner, which one is closer to 1. We also included Graham Fletcher's fraction cards. So if you're familiar with Graham Fletcher, he has a lot of subitizing cards that he uses. But we reintroduced the idea of subitizing into more of a conceptual understanding for fractions. So 2 years ago, our region participated in his Foundations of Fractions webinar. And through this, we were really able to build our knowledge around the importance of the conceptual understanding for fractions, and that students who are really flexible with their ability to see numbers in a variety of ways can be more successful problem solvers. So we started using these subitizing cards for mental math. They help the students subitize in primary and 1, but now we're really looking at how many different ways can you see these fractions and these equal parts. How do you see it? How many ways can you describe it? What do you notice? What do you wonder? So once we started using these in the classroom, we put those into almost like a free time center. So the students could have the cards as a go-to. They could sit down, they could play with a partner, and they could kind of use that as a tool to help them kind of visualize these parts that we're talking about. So I included a link here to the PDF for the fraction card. So you can see, you can easily snip those out, put them on a Google slide if you wanted to do more whole class. And I really like that there's just multiple ways for students to see all of these equal parts. So the last thing that I wanted to share today was Mathagon. So Mathagon has a lot of really great tools that are already pre-made. And I'm just going to kind of click on the Mathagon link here. So if you're not familiar, you can go to the activities and lessons in Mathagon, and there's all kinds of pre-made ones. The most popular one that we have been using were the game for the fraction bars. So once the students were familiar with how to use the fraction bars, they could play this game, and all you have to do is like highlight both of the dice. You can roll them, and the goal is for the students to create a fraction that would be greater than half. So they can move these into place. They can model using the fraction bars. I'm going to bring in the 2/4, and then we're going to bring in the half. And if it works, they get to keep it. If it doesn't work, they have to roll again. So they can see that this doesn't work. It's not greater. So then they have to roll again. And then they can, once they find one that works, they can move on to the next, which would be a fraction that's less than half. And over here, that once they find that, they can find a fraction that's greater than 1. So this was something that the students were also using in their free time when they'd finish their work, early finishers, but we were also using it as a game for mental math. So I found this was probably one of the most useful tools and one of the most useful games. The other one I wanted to share that we were using was with the pattern blocks. Just because, again, I had said before that our region had noticed that the students were still struggling with representing fractions with pattern blocks. So through this activity, if the hexagon is equal to 1, which part of the hexagon is not yellow? Excuse me. The students can kind of take a look over here, and they can insert their little equation, put their fraction in, and you just have to grow it a little bit to make it a little bit bigger. Which part of that hexagon is not yellow? So looking at how many equal parts they see and how many of those parts are not yellow. But I really like that the way that this activity is set up is that it's kind of looking at ways to make equal parts with the different pattern blocks kind of mixed on top of the hexagon. So really pushing students to think about, okay, well, this, this is not 3 equal parts. We have to figure out equal parts and what's my denominator going to be when I see this, because it's not going to be a denominator of 3. And I think, again, that's where students struggle sometimes, is having to kind of visualize their equal parts. So this activity we used in class as well, just to help build that understanding of representing fractions with pattern blocks. So, those are all of the tools that I really wanted to share that we had used over the last couple of years to help students build that understanding and that concrete visual understanding of what it means to have parts of a whole and how they can take that understanding and build on it to help them further their problem solving. I want to thank you for taking the time to visit this session today. And if you have any questions, feel free to email me. I included a link to the PowerPoint presentation here. Maybe I'll just pop that in the chat box before I finish, and that way everybody can have access. Thank you, Michelle, for moderating my session. And the replay will be available. I think they said for about a year it'll be available. So if anyone's interested, come next year. If you want to kind of revisit some of these ideas, it should be available for a year. Thank you very much. Enjoy the rest of your day.